There's that little divot there in the middle that has those little ridges up on top, like the things that stick up behind on a Turkish saddle.
Vaguely.
Y'all better go check on that. That's
I know the spot. I didn't know that.
that's a Jeopardy question on Jeopardy of Friday nights. You know what?
I don't think we were ever told what it was meant.
Right.
Really?
Yeah.
What it meant.
All right. Well, let's look it up. Let's look up Selaturcica in the back of your book. I'll bet it's in there.
Is that where your optic chiasm goes across?
Yeah, it's right next to that.
Turkish saddle would have been a lot easier.
Yeah, that's what it means on Google.
217 or 6.
Page 217 in your songbook.
Supposedly it's right here. Oh, yeah. That's
There it
right.
is, right there in the middle. And what does it say up here about it? I'm sure it says,
It's a bony saddle-shaped enclosure on the superior surface of the body.
okay, I'm sure back in the reading it talks about it as a Turkish saddle. That's what Selaturcica means. Yeah.
Google does.
Google's got it. That Google's pretty smart. All right. So you also remember that the hypophysis, the pituitary gland, which basically sits in that little thing that's shaped kind of like that, looking at it from the side, and it hangs down off of the brain, off of the this is the hypothalamus up here, right? And this is the pituitary gland, and it's kind of divided into an anterior and a posterior pituitary. There's a little membrane that comes across here that helps hold it in there. And that's that little dural sheet. It's called the diaphragma celli. It's like the diaphragm of dura that holds it in there to protect it. And just as somebody said something about the optic chiasm, think about that. If the pituitary had a tumor growing in it and it got bigger and bigger, one of the first things it pushes on is the optic chiasm. And the way those people are going to then know there's a problem is they're going to go blind in part of their eye, part of their visual field, because their optic chiasm isn't working right. Remember that? So keep that in mind, because
Where does the optic chiasm go through for?
it
like,
doesn't go
for
through this thing. It goes right around. It's up here,
Okay.
right around the neck. The pituitary gland makes 9 important hormones. You need to know these 9 hormones, just so you know. They're pretty easy. Most all of them use cyclic AMP as their second messenger. And here we go. So here's that nice picture that I drew for you. Here's the optic chiasm right here. It's kind of going around, but there it is on this diagram. So this is the hypothalamus up here, part of the brain. And remember, the hypothalamus is the major connector between the nervous system, the brain, and the endocrine system. And that's what we're going to be talking about here for a few minutes, is how does the brain control the pituitary gland? Hope you'll know the answer to that in a few minutes. But anyway, this thing here is called the infundibulum, you remember? Infundibulum is kind of the stalk. Most of your brains did not have it because they got ripped off in the harvesting of them. Here's the little diaphragma cella, that little fold of dura that kind of isolates this thing down here into the Selaturcica. The anterior part of the adenohypophysis, the anterior lobe, is illustrated right here in pink. And then between the two parts, there's a part that's called the pars intermedia. And then there's the back part, or the posterior hypophysis, or the neurohypophysis. Now, the reason it's called the neurohypophysis is that when you look at these under the microscope, you'll see that the neurohypophysis looks nothing, it just looks like nerve cells. It looks like white matter, lots of some cell bodies. It's gray matter, I guess you'd say, because there's some cell bodies, but there's an awful lot of what look like axons running through it. And they're connecting from up here in the hypothalamus. And the nerve cells connect all the way down here into the neurohypophysis. Now, the down and dirty here is that the neurohypophysis only makes 2 hormones. It only makes 2. And they are oxytocin and
the antidiuretic.
ADH, thank you. And ADH is anti-diuretic hormone. Okay, ADH, anti-diuretic. Now, what does diuresis mean? What's diuretic mean?
Urine?
What?
The urine?
Yes. So if you take a diuretic, what's it going to do? It's going to make you pee a lot, okay? That's what they used to give racehorses, Lasix, I think they still do. They give them Lasix, which makes them pee out a whole bunch of extra water so they can run faster. Okay?
Is that the whole run like a Russian racehorse thing?
Pee like a racehorse? Yeah.
Yeah.
Yeah. That's where it came from. But then if you've just watched a regular horse pee, it's still kind of amazing. Like, really? Yeah, it's like a fire hose down there. Yeah, so anyway, so this hormone is anti-diuretic hormone, so it makes you make less urine, okay? A diuretic would be a drug that makes you make more urine. What's the best diuretic in the whole world?
Coffee?
Water. Water's just as good. You drink enough water and by God, you'll make a lot of pee. If you drink coffee, it's even better. Coffee, tea, anything that has a little caffeine in it. Caffeine is a diuretic as well.
Is pineapple a diuretic?
Pineapple, I don't know. Good question. Google it. Okay. So 9 hormones, here we go, the picture. So there's only 2 of them made in the back. And this is an important concept. The 2 hormones that are released from the neurohypophysis are not actually made in the neurohypophysis. They're actually made up here in the hypothalamus. And they are then passed down to the neurohypophysis through these nerves, and then they're released down here. So you should say the two hormones I just mentioned, oxytocin and ADH, are manufactured in the hypothalamus, but they are released in the neurohypophysis down here. The pars intermedia makes only 1 hormone. I think that's the melanin thing. And then all the rest of them are made up here in the anterior hypophysis. So a lot of people kind of, when they say pituitary, what they're really talking about is this adenohypophysis. Adeno means glandular, right? Glandular cells. Adenomas, adenocarcinomas, glandular cells that turn into cancer and grow crazy. Anyway, adeno. So when you look at this area up here under the microscope, it looks very glandular. When you look at this back here, it looks very neural. It looks like neurologic tissue. Pars intermedia is kind of in between. Okay. Another thing that happens up here in this pars distalis. Now, I told you just now that for the posterior hormones, they're made up here in the hypothalamus. They're passed down here through the nerves and released from the neurohypophysis. The way it works up here is a little different. There are hormones that are made up here in the hypothalamus, which are basically releasing hormones or inhibitory hormones that then they're hormones, so they're just released into the bloodstream, and they have to come down here and affect the pituitary gland. Okay, well now if the hypothalamus was releasing hormones that are then released straight into the bloodstream and go all over the body, but it only has an effect right here, that would seem like a wasted effort, wouldn't it? You'd have to make a lot of hormone to have a little effect. So we have what's called a portal system. Now you guys know we have 2 portal systems in our body. One's in our belly, the hepatic portal system, which carries blood to our liver after it's gone through the intestines, but that's beside the point. We have a portal system up here in our brain. It's really tiny, but these are blood vessels that don't go back to the heart. In other words, they come into capillary system, a capillary network in the brain, in the hypothalamus, and then they reform into veins again, and they go straight down to the adenohypophysis, the front part of the pituitary gland, and carry the blood directly there. So it basically picks up all these hormones, these regulatory hormones, and brings them straight to where they need to be. This is a nice diagram of how that works. For example, the blood here comes in, goes in through the hypothalamus, nourishes this area, but then it's picked up by capillaries, turned into little veins, and these little veins, these portal veins, carry the blood down here along the infundibulum directly into the adenohypophysis, the anterior hypophysis, so that those little tiny bits of hormone that were created up here get carried kind of directly to here. Okay? It's not a difficult concept. It's not that important, but you do need to understand what it means when I say portal system. And the function of it is to get these releasing factors that are made up here directly to the adenohypophysis, which is the only place in the body they're going to work. Notice that the neurohypophysis is not included in this whole deal. It simply gets blood, and blood leaves and goes back to the heart. Notice that these two nuclei up here, these green ones, this is where the oxytocin and the ADH are made, and then these these hormones are carried in the nerve cells themselves down here into the posterior hypophysis and released from there. These regulatory hormones that we've been talking about occur in two kinds. One is a releasing hormone, which stimulates the synthesis and the release of more hormone. And then there's inhibitory hormones that cause the synthesis of less and the release of less hormone. Simple enough. The rate of secretion of these things is completely controlled by negative feedback, and we have some nice charts and diagrams that we'll get into here in a minute that show you how they work. And they're really very straightforward. This is not hard stuff. Anterior lobe, remember it's called the adenohypophysis or the anterior pituitary. The hormones, releases a number of hormones that turn on endocrine glands. And this, if you want to know something that's going to be on the test, I guarantee you this picture will be on the test. Because this kind of summarizes the whole deal in one picture. Okay? Now, let's just go over it with you, and I think it'll make pretty good sense to you. So here, let's talk about the posterior pituitary first. Notice that these hormones are manufactured up here in the hypothalamus. They travel down on nerves, through nerves, actually travel right through the axon to get down here, and then they're released down here. The two that are released down here are ADH, anti-diuretic hormone, which has its effect on the kidney, and the kidney only, and the other hormone is oxytocin. The oxytocin is a drug, is a hormone that drives labor. So this is the hormone that makes you go into labor. It makes your uterus start to contract, and do that every 2 minutes, and then every 1 minute, and then here comes the baby kind of thing. It also has an effect on the glands in your breasts to cause the milk to start being released. Once the baby's born, a lot of this is stimulated by the baby suckling on the nipple, which then feeds back up here, causes release of more oxytocin, and causes the milk to come out. People often call oxytocin the nurturing enzyme because it plays those roles that we just talked about. In men, what does it do? Well, not so much. It causes the muscles in your prostate gland and in your ductus deferens, the vas deferens, to squeeze down when it's time to have an ejaculation. We'll get to that later. MSH is the only one made in the pars intermedia here. It's the melanocyte stimulating hormone, and you see that the only thing it really affects is your melanocytes and how much melanin your body manufactures. Now, if you go out and lay in the sun, you make more melanin, and you get tanned. If you're from a darker skinned race, your MSH level is just programmed to make more melanin, and thus your skin is darker. But if you go back and think about what separates us as peoples, and you look at that skin, those skin microscope slides that I'm sure you looked at when you were in 231, at least I hope you looked at, the only difference between black people and white people is one thin little tiny layer of cells in the deepest layers of their skin. That's the only difference. If you didn't look at that when you were at in 231, ask me. I'll show it to you because I think it's one of the most incredible things that has led to incredible problems throughout the world, and still does, is the colors of our skin. And it's such a minor part of who we are. It's just incredible. All right, so here's the rest of the hormones now that are released by the adeno hypophysis right here. The releasing factors are released up in here, and they come down here and they cause the release of these different things. Now, for example, let's take thyroid stimulating hormone. Thyroid stimulating hormone is released by the adeno hypophysis here. It goes out into the bloodstream, it goes to the thyroid gland, and it says, thyroid, it's time to kick it into gear, make more thyroid hormone. And so TSH, thyroid stimulating hormone, which is one of the 8 hormones made up in here, comes down, circulates through the blood, goes to the thyroid gland, and that's where it has its effect. The thyroid then makes more thyroid hormone. Thyroid hormone is actually made in the thyroid gland. The T3 and T4 are both forms of thyroid hormone. For example, growth hormone. Growth hormone is released by the adeno hypophysis here, goes out into the blood, circulates around, goes to the liver, goes to the muscles, and causes you to grow more bone, muscle, and get taller, and so forth. Prolactin causes stimulation of your mammary glands to grow during pregnancy and also to grow during puberty. Enough said there. FSH and LH, follicle stimulating hormone and luteinizing hormone, are both sex hormones that cause our testes to make sperm and cause our ovaries to make eggs mature and ovulate so that you can get pregnant. The last one over here is ACTH, adrenocorticotropic hormone, which is released by the pituitary. It goes to the medulla of the adrenal gland. And I'm sorry, it mostly goes to the cortex of the adrenal gland. Adrenocortico, get it? Adrenocortex. It causes the release of all the steroid hormones, cortisol, corticosteroid, so forth. Notice there is also a direct connection between the brain and the medulla, the middle part of the adrenal gland over here, that causes the direct release of epinephrine and norepinephrine. This is the old fight or flight thing. When you see the tiger walk in the room and you get psyched, you have a direct connection between your brain to your adrenal gland that causes release of that epinephrine and does all the things that we talked about happen for you when you go into fight or flight. Okay? So there you have them. Now there's a few more. There's some releasing factors that are made up here that we didn't talk about just now, but we will, that are made up here in the hypothalamus that go through that little portal system to get down here to this pituitary gland to cause these to be released. So in order to get TSH released, you have to have thyrotropic releasing hormone made up here, goes down here, it causes the TSH to be released. Hold on, next slide or two. Posterior slide, posterior lobe, we've talked about enough really. Only makes the two hormones, ADH and oxytocin, and it contains all these unmyelinated axons, and that's what actually carries the hormone down into the pituitary. This is a review. I put it in here twice to go over something else, but I don't remember. Okay, that's the pituitary gland. Okay, pituitary gland called the master gland. Depending on how much releasing factor or how much stimulating hormone it releases, that tells the other endocrine organs how much hormone to make. Okay, so that's why it's called the master gland. Let's talk one by one now about some of these other endocrine organs. The thyroid gland. Thyroid gland lives right here in your neck. Anybody in the room ever had a swollen thyroid, had a goiter? Anybody take thyroid hormones? Were you hypothyroid?
I have Hashimoto's, so.
Hashimoto's, to quiet down. Okay, write that word down, Hashimoto's. It's a form of problems with the thyroid gland that we will get to. I want to say allergic, but that's not really the word. It's an autoimmune disease where your own body attacks your own thyroid. Thank you. The thyroid gland is it has a very universal look to it throughout. It's the same all the way through. There are no ducts in it, remember. And basically, it's really easy to identify under the microscope, and you need to be able to do that. But basically, it's just made by a bunch of follicles. These follicles are full of thyroid hormone in the middle, called thyroglobulin. And around the edge of each one of these follicles, it's completely lined in cuboidal epithelium. Now, whether you know it or not, back when you were in 231 and you had a test over tissues and the different types of cells, you know, the thin, flat ones, the squamous ones, and then the square ones called cuboidal, and then the tall ones called columnar. This was the example that was probably on your test, and there was an arrow pointing at these thyroid cells because they're perfect cuboidal cells around a follicle. They may not have even told you what the tissue you were looking at. They just wanted you to be able to identify the shape of the cells. Anyway, so this colloid that lives out in the middle is kind of thick and viscous. It is thyroglobulin, which is a combination of thyroid hormone and proteins. Surrounded by lots of blood vessels in the neck to supply blood to the thyroid. The two forms of thyroid hormone are called T3 and T4. They're both made by these follicle cells. They're spit out into the colloid, out into the middle of these things, and they contain a lot of the amino acid tyrosine. These contain 3 molecules of iodine. Thyroxine contains 4, as it says here at the bottom. Now, the thyroid has a very intense blood supply because it's a very bloody organ, and it's got a lot of manufacture of these proteins going on. It needs a lot of blood. And just for your interest here, I love this. I don't know why they put this picture of Grandma up there, but sweet Grandma with her glasses has a thyroid gland, just like any other human would. Notice this is the thyroid cartilage, which is part of your Adam's apple, basically. And the thyroid gland is located just below that. And the way we used to always feel for the thyroid gland is you'd come around, I'm going to touch you if you don't mind, you come around behind somebody, you kind of put your hands on their thyroid cartilage, on their Adam's apple, slide just below that, and then say, would you please swallow? And when you swallow, your larynx goes up and your thyroid goes up. And usually if there's a lump in the thyroid, you can feel it pretty obviously by doing that. Yeah?
I have one if anybody
You have a nodule? Let's do that. We'll have a field and neck session over in lab. How about that?
Hey, so for women that don't have the Adam's apple,
Huh?
for women that don't have Adam's apple.
Women do have an Adam's apple. It's just not as prominent. It's the same cartilage. It just shows up more in men because it's longer. That's why men's voices are lower, is because their larynx is bigger and their vocal cords are longer and they're like playing the bass notes, right? Okay, notice that there is inferior thyroid arteries coming off of the subclavian artery out here, supplying blood here to the thyroid. There's also a superior thyroid vessels that come in here from the top. There's 3 sets of veins. There's an inferior set of inferior thyroid veins coming out the bottom. There's a middle set of thyroid veins coming out the side. And there's a superior set of thyroid veins coming out the top. So 2 sets of arteries, 3 sets of veins, lots of blood, very complicated area. This is the view from the front, and once again notice here's the thyroid cartilage, here's the cricoid cartilage, and then these are the tracheal cartilages behind there. This is one of the reasons it's so hard to do a tracheotomy, a tracheostomy. If you need to put a tube in somebody's windpipe to breathe for them, normally we do it right here between the second and third tracheal cartilage. But in order to do that, you kind of got to go right through the middle of the thyroid gland. So you kind of clamp, tie off, right, and just separate this is the isthmus of the thyroid gland, the right lobe, left lobe, and isthmus, and separate it, and then you can get through. That's also why a lot of times the EMTs these days, they've all been trained to do cricothyroidotomies, which is basically making an incision right here in this membrane here, right below the cricoid cartilage. And you can actually feel that membrane usually. And they just take a little knife and make an incision and stick a tube right in there. Actually, they have kind of a needle with a tube that feeds off of it. You ever seen one of those done? Cric? Yeah. They're amazing. And we didn't figure that out till about 25 years ago. Prior to that, the only airway was either nasal intubation through the mouth or tracheostomy. So here's what the thyroid looks like. You need to look at them under the microscope. You need to be able to identify them. This is what they look like in real life. And notice that the thyroglobulin usually kind of retracts as it's prepped, as it's stained and so forth. It kind of retracts from the edge. But nonetheless, it's pretty much, and some of them have fallen out too, so there will be nothing in the middle. But this is what it would look like in life. The follicle cavities would be completely full of the thyroglobulin. These are those cuboidal cells that come all the way around. Lots of blood vessels, lots of capillaries you can see here. The other kind of cells that you need to know are there, and I'm not so sure I can usually identify them under the microscope, but they don't make up part of the follicle. They're called the interfollicular cells because you see they live between the follicles. They're called C cells, and they make calcitonin. Calcitonin is that hormone that helps you control your calcium levels. Now you got to keep the thyroid and the parathyroid straight. Okay? The parathyroids are really tiny, and they live right behind the thyroid. Let's finish the thyroid first, though. The hypothalamus up here releases this releasing factor called TRH, thyrotropin releasing hormone. It gets in that little portal system, picked up by those little bitty blood vessels, carried down here to the adenohypophysis, where it affects the pituitary gland and says, hey, release more thyroid stimulating hormone. So sure enough, it does, as illustrated right here. It causes this to release TSH. TSH is thyroid stimulating hormone. Thyroid stimulating hormone goes out and floats through your bloodstream, goes to your thyroid gland, and makes your thyroid gland kick in and start working and making more T3 and T4. Once it restores enough, then the elevated levels of T3 and T4 feed back up here to the hypothalamus and tell it to shut down, quit releasing hormones. Okay, and that's the negative feedback that works there. So be sure you understand that. I think the thyroid one is probably the most straightforward of all of them, but these exist for all of these hormones that are released up in the adenohypophysis. TSH, the nice thing about TSH now, and of course you just cannot believe how much stuff is new since I started practicing in 1975. We could measure thyroid hormone, but we didn't know the difference between T3 and T4. They just lumped them together, it's thyroid hormone. We didn't know how to measure TSH. Now you can measure TSH. So somebody that's hypothyroid, that's not making enough thyroid hormone, you can check their TSH level and see what the problem is. If the TSH is low, it's because their pituitary is not releasing enough, so maybe the problem is in their pituitary. But if their TSH is really high, the pituitary is telling them to secrete more thyroid hormone, make more thyroid, but it's not working, then it's usually a problem right here in the thyroid gland, like Hashimoto's, which have, so you probably run really high TSH levels, but it's not working. It's not affecting the thyroid the way it should.
What I found out was interesting is I found out about 8 years ago I'm allergic to wheat, not necessarily gluten, but wheat.
Mm-hmm.
And my doctor said that the wheat proteins look very much like the thyroid proteins, and so when you eat wheat, it makes it even worse.
Yeah.
A lot of the people with Hashimoto's.
So it's thinking there's thyroid hormone, but it's really just wheat out there in the bloodstream. Let's not make this any more complicated. So y'all don't worry about that stuff. So anyway, that's what TSH does. It's really important in this whole scheme of thing. Now let's talk about thyroid hormones for just a minute. What does it mean if you have too much thyroid hormone or too little thyroid hormone? Well, because the fact is that thyroid hormones affect almost every cell in your body, and they set the level of activity of those cells. And it does that by binding to these receptors, gets through into the cells, they go into the mitochondria, the nuclei, and so forth. It's really important in kids. If kids don't have enough thyroid hormone, then they don't develop normally. So if there's usually when kids undergo a developmental workup, say they're shorter than the other kids in their class, one of the first tests the doctors will do will be a thyroid level and a TSH level and see if their thyroid is working properly, because it may not be. The calorogenic effect, that just means if your thyroid has got your cells all turned on, you're burning up more calories. Everything is working overtime. Now,